talk about the one type of reaction we have not talked about yet that doesn't really fit any of our other categories, and it's called combustion.
Wait, was there any no reaction on that thing?
I can't tell you that. There are 3 people who haven't taken it yet. All right, so the combustion reaction is kind of a fun reaction. There's fire. Anytime you have a combustion, you basically have fire. And so we're going to go through this today. If we have a little bit of time tomorrow after I feel like we've adequately reviewed, then I've got a single replacement demo that's pretty fun, and I've got a combustion demo that's pretty fun that we might be able to do, okay? We'll see. Honestly, Ernst is having an issue today. The gas is evidently not working, so I can't do my demo without gas. So if we don't have gas tomorrow, then I would only be able to do the single replacement. I was thinking about maybe doing that so that you could see it. That's a combustion reaction, right? So, all right. But we've got to review for the test first. That has to be top priority. So we'll see if we get to those other things or not. But a combustion reaction, here's your 3 combustion reactions that they give as examples, okay? So then number 19, it says, what are the products in all of those combustion reactions? They're all the same, aren't they? Well, yeah, they are all gases, right? And that's just because combustion is a fire, so anything that comes out of that reaction is going to be a gas because it's so hot. But what are the 2 products? Carbon dioxide and water. Guess what? Those are always your products in combustion reactions, at least in the type we do in here, okay? So carbon dioxide and water, that's it. That's all you have to remember for the product side of the combustion reaction, okay? What reactant is common in all of these combustion reactions? So there's one reactant that's the same every time. And you probably would have known this if I had just asked you, what does a fire need to burn? Oxygen, right? Okay, see? Oxygen, oxygen, oxygen. Oxygen has to be a reactant in a combustion reaction for it to happen. Now, you might not have known that when something burns, it gives off carbon dioxide and water vapor. But that's what's actually coming off of a fire, okay?
Is the reactant come first?
What? Say that again?
Is the reactant come first?
Yeah, reactant is on the left side, remember? So products are on the right side. Okay, so that's, again, you just kind of have to learn the template on these. They always have some compound. The only thing that's ever different in these is this part right here, right at the very beginning, okay? Notice everything else that comes after that is the same, except for the coefficients, okay? So then number 21 says, the fuel in most combustion reactions is a hydrocarbon. Using the examples in Model 2, write a description for the classification of substances known as hydrocarbons. All right, so these out in front here, the ones that I said are always different, those are the hydrocarbons. What do you notice is the same about all of those hydrocarbons? Yeah, hydrocarbon. They contain carbon and hydrogen. That makes sense, doesn't it? Okay, so that's a hydrocarbon. It contains carbon and hydrogen. Now, hydrocarbon could contain other things, and maybe sometimes we still call that a hydrocarbon. That's a little sloppy. Technically, a hydrocarbon should just be carbon and hydrogen, but you might see that in terminology every once in a while. But to be a hydrocarbon in most common language, it has to at least contain a carbon and a hydrogen, okay? So now we're going to predict the products of the following combustion reactions and balance each. This should be super easy, all right? Letter A, what's the products? CO2 plus H2O. Okay, now before I balance this one and the next one, what's my product? What are my products on the bottom one? CO2 and H2O. Are you sensing a pattern here? It's always CO2 and H2O, always, in a combustion reaction, okay? That's all you have to do. You see it's combustion? Oh, CO2 and H2O. Now the trick sometimes is, yeah, that's what I was going to say. The trick is recognizing this as a combustion reaction, Okay, so how would you recognize, let's say that you only have what's on the left side here, what's on the reactant side. How would you recognize it's a combustion? Okay, for one thing, it's got oxygen, right? What's the other thing? Well, yeah, but oxygen is always O2 in whatever reaction it's in, right? If it's by itself. Yeah, the hydrocarbon. So the two things that you're always going to have on the reactant side, a hydrocarbon and oxygen. You kind of just have to train your brain on this one to notice, oh, okay, this looks like a combustion because I've got a carbon-hydrogen compound here, and there's oxygen. So then as soon as you recognize that's a combustion, then you just say, oh, okay, so CO2 and H2O, those are my products. And then the tricky part on this is always the balancing, okay? Is a 5 going to work out for us? Because that's what I'm going to want to put there first is a 5.
On CO2.
Yeah, on the CO2. So let's see, if we put a 5 on the CO2, we have to put a 6 on the H2O. That gives us 10, 16. Yeah, that works. Okay. So 5 here because there's 5 carbons on this side. And then we have to balance the 12 hydrogens on this side, we have to put a 6 right here. Okay, that gives us 10, 16 oxygens. And then they already put the 8 over here, so that's 16 oxygens. On the second one, they're nice enough to give you the coefficients on the left side, which helps a little bit, so that you can already see that you're going to probably have to put a, 4 on the CO2, right? Because there's 4 carbons there on the left side. And then you're going to have to put a 2 over here because there's 4 hydrogens also. So that helps out with your odd-even problem that you have, and that should do it, I think. Okay? Now, what they're saying on 23, and you're not going to have to worry too much about this. I'm probably not going to put one like this on your quiz or test. But you can have a compound like this. That's not exactly just a hydrocarbon. That also has an oxygen in it, right? And then same here. This is glucose, C6H12O6. Okay, they can also undergo combustion. All right? So if it's got an oxygen in there, what do you think the products are going to be? Yeah, it's still the same. It's still a combustion, right? And I said anytime it's a combustion, it's CO2 plus H2O for the products, okay? CO2 plus H2O. So this one is maybe a little trickier. They're a little trickier to balance when they're like this because now you have oxygen everywhere, right? So on the first one, I'm going to want to put a 3 in front of the carbon and a 4 in front of the H2O. Does everybody see I'm putting a 4 in front of the H2O? On the right side. How many hydrogens do I have on the left side? Yeah, so you have to be careful there. There's 7, and then they put that 1 at the end. Why did they do that? Well, it has to do with the way it is structurally because it shows that one of those hydrogens can come off, okay? Or it can accept a hydrogen from somewhere else. It has to do with acid-base chemistry, so you don't have to worry about that necessarily, but you have to watch out for that, excuse me, because you've got 7 here, 1 here, so there's a total of 8 hydrogens, so we need to put a 4 here, which is good. That works out better for us than, I mean, there's nothing we could have done to balance that 7. And then put a 3 here, and let's see what that does. So now how many oxygens do we have on the right side? Boy, I'm hearing all kinds of numbers. And none of them, okay, there we go. Finally heard the right one. It's 10 on the right side, right? Because I've got 3 times 2 is 6 from the carbon dioxide, and then there's 4 from the H2O because I put a 4 in front of that H2O. 4 is 10. All right, so I need 10 total on the left side. That's tricky, isn't it? All right, so we've got another problem. They weren't as nice this time to give us the coefficients on the left side of the equation, so we've got an odd-even situation, right? Now, which one is causing the problem on the left side? Yeah, C3H7OH, right? Because that's the one where we have the odd number of oxygens. So let's put a 2 here and see if that helps things out. Now we're going to have to go back and change all our other coefficients now. I can't do this without destroying that one, so... yeah. I can, yeah. Hang on just 1 second. Okay. So we put the 2 there in front of the C3H7OH. So that changes it. Now we've got 6 carbons, so we've got to put a 6 here. Now we had 8 hydrogens, now we have 16, so we've got to put an 8 here. And I think that's going to fix our problem, right? So now we got to figure out how many oxygens we have on the right side. We're struggling with this. 6 times 2 is 12, okay, plus the 8 from over here, so that gives me 20. So then I need to put a, you got to be careful here, don't put a 10 there, right, because we've got 2 here. Yeah. No, a 9, right? 9 times 2 is 18, plus the 2, that will give me 20. So now I'm balanced on both sides. I would make a tally for that one if I were you. I just didn't have room for it. Combustion, they're easy to predict the products. It's always really hard to balance them. Okay, that's always the tough part with combustion.
So on the test, there's not going to be like some reaction side or something in the
Like an OH like this? Probably not, no. You get it figured out?
No, this is
Okay. So then this last one here, you know what? Just for the sake of time, if you want to try and balance it, you can.
No,
That one's actually, this one's not bad, actually. I think, oh, the other one's stressed you out? Okay. Well, we'll take a break then. I don't want you guys to get too stressed out here. But the other one actually is quite a bit easier, and that's just photosynthesis. So you might have memorized the coefficients that go on that one. Actually, it's cellular respiration, sorry. You guys realize that cellular respiration is a combustion reaction? So when cells take food in your body and burn it, that's a combustion reaction, okay? Now, it does it in a series of steps, so it's not exactly the same. But if you go with the overall equation there, it's just a combustion, okay? All right, number 24. For each of the reaction types in Model 1, explain why a combustion reaction can't be classified as those types. So let's look at the combustion reactions up here. Why could we not call this a synthesis reaction? What do we have to have for a synthesis? What's the main thing we're looking for in a synthesis reaction? Yeah, it's a combination into one product, right? We don't have that over here. We have 2 products, okay? Why can it not be a decomposition? Yeah, because decomposition usually has one reactant that breaks apart, right? That's not what's happening here. Why can't we call this a single replacement? See, that looks kind of good, right? Maybe this is... Because this is a compound, this is a single element, right? So that almost looks like single replacement, but why can't we call it that? What is the oxygen doing here? Yeah, oxygen's not happy just going to one of the partners here. It's going to both of them, right? That doesn't happen in single replacement. You see that? The oxygen is going with the carbon and with the hydrogen, okay? So we don't have a category for that, a relational category, right? Unless you want to talk about, like, I guess someone who has 2 wives or something. I don't know. That could be that category, but that's not single replacement, right? Well, let's not bring religion into it. Okay. So then we're getting out of hand here, people. Come on. All right. So why is this not a double replacement?
because it's not the same
there's not 4 different.
Yeah, the double replacement requires 2 compounds on the reactant side, right? And there's a single element on the reactant side. So this, it just doesn't fit any of our categories. So hopefully when you see it on a test and you're thinking in terms of the main four, you'll realize, hey, this doesn't fit. And then maybe that will jog in your brain, oh wait, this is a hydrocarbon and oxygen. This is combustion, okay? So then once you know it's combustion, you just write CO2 plus H2O on the product side. It's simple as that, okay? So that's that. We're going to have a quiz on that tomorrow. Okay, I'll give you a practice on that right now, and I put the answer key on the back of the practice so you can look at it as you're doing it. The other thing that will be on the quiz tomorrow is just being able to identify each of the reaction types. If I just give you a reaction, you can tell me, oh, that's a synthesis or that's a decomposition. No, you're just identifying on that part. Well, you're doing the combustion part, and then you're identifying. That's all. Yep. Okay. I'll turn this off.